morning, classes. It is Monday morning, April 6th, and this is for dental and fire. We are starting chapter 14 this week. Very important chapter for both classes. Kind of ties a lot of the concepts together that we've been talking about all year. It's a good chapter for you to kind of figure out what you know and what you don't know. And basically, in the format that we're using now, give you the opportunity to do a little research on your own, make sure that you understand the concepts. I'll guide you through it just like I did last chapter with a series of questions, and make sure that by time the end of the process, as you can see, it was a very short assessment. Make sure that you understand the material completely. Again, up to you to contact me with questions. I've had a number of people that have been using email to communicate with me almost daily. That's great. I'm on there checking it constantly, so make sure that you use that format. You can communicate through Google Classroom as well, but ask questions if you have them. Chapter 14 is on the respiratory system. The respiratory system has two major functions. We talked about other systems that have multiple functions, tens, hundreds of functions sometimes. The respiratory system has two basic functions: to bring oxygen into the body and to remove carbon dioxide. That is it. As you can see up here, I've written a couple questions next to the functions that I just discussed. The oxygen and the carbon dioxide, you might wonder why we have this intricate system of lungs and respiratory passages, obviously pathways for infection, pretty big topic obviously right now. Why would we make ourselves susceptible to the external environment, allowing things to get in and cause infections? Obviously the respiratory system is pretty important. Bringing in oxygen allows us to combine it with glucose in the cells to perform cellular respiration, which is a topic we've talked about basically since the second chapter. Carbon dioxide, and that question I have up here where's it coming from? It's the waste product of cellular respiration. It's not a very dangerous waste product, but if it starts to build up in the cells and in the bloodstream, it can cause major problems with disruption of homeostasis, acidosis, because carbon dioxide forms carbonic acid in the bloodstream, so we have to get rid of it. So we exhale it. So every time you breathe in, you're bringing in the oxygen, and then the CO2 is coming out at the same time. So again, the respiratory system's two major functions: bringing in oxygen, removing carbon dioxide. Now, an air trace. Where's the air going when you breathe it in? Now, you should breathe through your nose. That's the proper way to do it. Not that there's a proper way, there's no book on it, but your body has evolved to bring the air in through your nose, through your nasal passages, because the nasal passages, will filter the air out with hair and with mucus. It moisturizes the air a little bit, which makes it easier for it to go through the process it's going to, which is gas exchange. And it also warms it up a little bit too, which increases the molecular speed, which allows for gas exchange and diffusion to occur more efficiently once the air does get to the lungs. But you can breathe through your mouth as well. Obviously, you know that. So when we start with the air trace, it's nose and mouth. Then it goes to the pharynx, which is the common area at the rear of the mouth. And then the trachea. The trachea is the beginning of the airway. The trachea is covered by a flap of cartilaginous tissue. It's about the size of the end of your thumb, called the epiglottis. The job of the epiglottis is to snap over the opening of the trachea when you're eating and drinking. Obviously, you don't want food and water going into your lungs. That's called choking. That can be obviously very detrimental to your health. So the epiglottis's job when you're not breathing is to cover the opening of the trachea. The trachea then leads to the bronchi. Right? The bronchi are the two branches that come off, and I'll post some diagrams. You can look at some diagrams online of what this actually looks like. But it breaks off almost into an upside down Y. So one of each of those tubes, which are smooth muscle and cartilaginous tubes, are going to one of each of the lungs. Once they get to the lungs, they break into bronchial tubes. There are literally tens of thousands of these tubes. They get smaller and smaller and smaller, and then they terminate in little grape-like clusters called alveoli. A singular form of that would be an alveolus. You have about 300 million of these between your two lungs. So there are a lot of these tiny little air sacs. And this is where the nuts and the bolts, the actual thing that the respiratory system does, occurs: gas exchange. Gas exchange occurs in the alveoli. And the alveoli are surrounded by capillary networks. Those capillary networks, obviously, the little blood vessels that allow for diffusion to occur. The oxygen is going to pass out of the alveoli, or out of the lungs, into the bloodstream. And then the CO2 is going to pass the other direction, out of the bloodstream into the lungs, so it can be exhaled. Obviously, that whole process happens 15 times a minute or so every time we breathe in and breathe out, but this is constant. Diffusion, again, movement of a substance from an area of greater or lesser concentration. So when you bring in a breath of air, the blood that it's interacting with, and again, this blood is between layers of tissue. It's not that you have blood in your lungs. We talked about this when we were in class as well. But there's that one layer of tissue, the single layer of tissue around the alveoli, and the single-celled layer of tissue around the capillaries, and oxygen and CO2 can pass through those. So that gas exchange occurs, and then we have the high oxygen blood now returning to the heart. Now I've done the second sheet, the second board. I usually save this for the second day of lecture, but I figured this would be kind of a seamless transition for us to do right now, just to kind of explain to you what happens. Try to move this out of the way here so you guys can see it. All right, here's an alveolus. This is a bronchial, this tube right here, and this is the termination. Just a little air sac. And again, there's millions of these in each of the lungs. So when the oxygen comes in, it's going to be in high concentration inside of the air sac. It's going to pass into the capillaries that are around the outside of the alveoli. Now, where is that blood coming from? This is where we tie in past chapters. The blood's going to be coming from a branch of the pulmonary artery. And if you remember, the pulmonary arteries come off the top of the right side of the heart. And I told you when we were in class talking about the heart, that the right side of the heart is going to pump low oxygen blood, high CO2 blood, to the lungs so gas exchange can occur. I mentioned that in that chapter, and I said we talk a lot more about it. This is when we're talking a lot more about it. So that blood is going to move to the area around the alveoli. O2 is going to pass through the walls of the alveoli into the bloodstream. CO2 is going to pass out. And you can see how I've drawn this here. This is blue, again, representing low oxygen blood. And as we get through the other side of the alveoli, now it's going to change to red. And again, it doesn't change. There's no color change. This is just for us to understand the concept a little bit easier. So the CO2 is going to pass out of the capillary into the airspace, and it's going to be exhaled. And now the blood's going to go back to the left side of the heart. Now it has high oxygen, low CO2. It's going to go back to the left side of the heart through the pulmonary vein and return that to the left side of the heart, and then the left side of the heart will pump that high oxygen blood to the body so the cells can get it for cellular respiration. So that's all I'm going to do today. I'll kind of review this in a couple of days with you, ask you some other questions, but kind of let this sink in. Take a peek at the notes that I posted this morning and make sure that you understand these concepts. I'm going to have a lot of questions that are specific to your disciplines, being fire and dental. I'm going to try to do the best I can to find some topics that relate to respiration and your specific fields as I ask questions throughout this week and into next week. Have a good day.